Good afternoon, everyone. I'm Giorgio Veronesi. I'm president of the European Federation of Chemical Engineering, EFCE. I've been in the board of EFCE in various positions for almost 9 years, and currently I'm in the second term as president. I'm a chemical engineer by training, graduated in Padua, Italy, and been spending the whole of my career in the engineering construction business, involved in many projects around the world with several assignments overseas. I'm very happy to be introducing this webinar organized by the Early Career section of EFCE on elevating your career, essential skills for professional growth, a theme of great interest for our younger colleagues. Let me say something about the Spotlight Talk series. This is now our fifth year that we are holding this event. We started in 2020 in order to keep the chemical engineering community together during the COVID pandemic. But the event was, this series was so successful that we decided to transform the Spotlight Talks in a regular feature of EFCE program. We have now 2 series in even years, spring and autumn, like this one, and 1 series spring in odd years, when we are holding the European Conference of Chemical Engineering in autumn. Let me take this opportunity to remind you that next year the conference will be held in September in Lisbon, an event not to be missed. This fall, 13 of our working parties and sections, sustainability, mixing, electrochemical engineering, high pressure technology, food, loss prevention and safety promotion, agglomeration, multi-phase fluid flow, static electricity in industry, education, polymer reaction engineering, thermodynamics and transport properties, and early career chemical engineers, this one, are delivering 2 weeks, over 2 weeks, a short session of 3 or 4 talks focused on specific topics by leading industrial and academic experts. The complete program is available on the EFCE website. This is the last one of our webinar, and the recordings will be available on EFCE YouTube channel pretty soon. Some of them may be already available online. EFCE promotes scientific collaboration, supports chemical engineering activities in 30 European countries, and we represent more than 100,000 chemical engineers in Europe. The working parties and section of EFCE cover all major specific aspects of chemical engineering and are in fact the core of the organization, forming the scientific engine that drives many of EFCE activities. They provide an important forum for technical exchange and networking among chemical engineers in Europe. Before concluding, I would like to thank all the people who work hard inside the working parties sections and EFCE in general for this initiative to happen and be successful. In particular, many thanks to EFCE Martin Pou from the Scientific Secretariat in Toulouse, who did most of the work from the conceptual, setting up and practical phases. I thank you for your attention, and I wish all the speakers and the attendees a fruitful and successful webinar. And then I would give the floor to Silvie Mueller, Vice Chair of the Early Career Chemical Engineer section, to introduce the works. Silvie, please.
Great. Hi, everyone. Thank you, Giorgio, for the warm welcome and kind introduction to this Spotlight talk. So let me start by sharing my screen because I want to give you some context on today's event. So I am the vice chair of the section called EFCE, Early Career Chemical Engineers. And our section has the objectives to bridge the gap between graduation towards professional life. We want to facilitate that by sharing experiences, giving some insights and information, by upskilling opportunities and of course networking, and then also representing ourselves as the early careers with one voice. I think we have an interesting definition of our early career being, which is not based on age but on experience. So if you are working towards a bachelor, then it is approximately 8 years after your master's degrees or 4 years after your PhD degrees that you are early career. Then just a quick look at our organizational structure. We are consisting of a board of 10 members in total with a chair and vice chair. And then currently we have a total of 43 general members that are spread all over Europe, as you can see in the map here. And we are still growing. So we are a very, very young new section of the EFCE. Now, what do? We have several task forces where we work on different topics. These are only some of them. And most importantly, it is social media, but also, of course, the youth program for next year's ECCE in Portugal, as Giorgio just mentioned. And then, of course, most importantly for today, it's the EFCE Early Career Spotlight Talk. So here, this task force consists of Morgan, Alper, Sophia, Shirin, and Xenia. I have seen some of you also in the audience, so welcome. And then, of course, from the EFCE secretary, Martine Fuchs, we have much technical support here, and she is running the whole series of the Spotlight Talk, so not only today's webinar. Okay, without further ado, let's continue with our today's webinar. It's called Elevating Your Career, Essential Skills for Professional Growth. And I want to share some notes that are important for today. So first, this topic was chosen by a vote from all of our general members. So I think having so many participants online, I see we are 70 persons right now. That's great. It is a success already, I would say. So thanks everyone for choosing this topic. Then you as participants, you are mute, but you can go ahead and post your questions in the Q&A function here in the Zoom call. And then the Spotlight Talk will be recorded. It is already running and then uploaded afterwards on YouTube. We have 4 talks in total. Each of them are approximately 25 minutes presentation and 5 minutes Q&A afterwards. Okay, now we are ready to go. It's 2:10, perfect. Silvia, welcome to the stage. I'm stopping my screen sharing. You can turn on your camera and start your screen sharing if you like. And then the floor is yours.
Thanks, Silvie. So I hope you can see my screen. Just short feedback. Perfect. Good. So hi, everybody. So today I would give you a short talk about Lean and Six Sigma. So the agenda for today is what is Lean and Six Sigma, and I would like to give you a really short introduction of key Lean and Six Sigma tools and methods. Of course, I prepared somehow case studies showing the Lean and Six Sigma applications. And the last one is also shows a connection between Lean and Six Sigma and Agile methodologies, knowing that there will be a more detailed and separate part of Agile methods later on. So before we get started, maybe a few words to my side. My name is Silvia Hinken. I'm with Merck now since 2005, so quite a while. From background, I've got a bachelor in process engineering and an MBA in engineering management. And I also started my Lean and Six Sigma career many years ago when I was in quality. So I did my green belt and then continued this path and did my black belt. And now I'm a master black belt in Lean and Six Sigma. And around 4 or 5 years ago, I also started working with the Agile methods. So I'm a Scrum Master and also design thinking trained. So you see here, I try to combine all these different words together, which then support us in our daily life, in our projects. My motivation is really, if I do it not now, when else? So I think now it's the best time for it, and I hope I can give you some insights within the next few minutes about Lean and Six Sigma and what it is all about. So what is Lean and Six Sigma? Lean and Six Sigma is nothing new. Honestly, it's already quite old. And many methods were developed after the World Wars. So in the 1930s, a man called Shirin started with the SPC cycle, and then Deming followed in the 1950s with the PDCA, so Plan, Do, Check, Act cycle, and also Mr. Ono in the 1950s about the Toyota production system. So as I mentioned, many things derived during the World Wars as we had limited resources and we had to make the best of our processes and our resources. On the other side, in the 80s and 1990s, management systems emerged, and Motorola and GE and also Lean Enterprise Institute started with Six Sigma, DMake, and Lean. And within Merck already, Lean and Six Sigma activities really started in 2005, and the journey still continues in several different departments in several different ways. So here it's not just a one-hit wonder, but it's still a continuous improvement way of thinking. And I hope I can give you some insight what does it mean within the next few slides. So when we talk about Lean and Six Sigma, there are two aspects. So first is the Lean aspect, which means do the right things. Lean is focusing on maximizing customer value, and it tries to eliminate, minimize waste within our processes. It's about streamlining our processes to be faster and, of course, enhance efficiency. So Lean is focusing on a waste-free process. Six Sigma, which is from the statistical point of view, is about do the things right, which means it is a data-driven approach. It's not about gut feeling, but using data that is available. It's about identifying and removing causes of defects, minimizing the variability, which means deliver constantly high quality, and of course, right the first time. So Six Sigma focuses on the variation-free processes. And now, if we bring them together, I think it's a really good combination. And what both aspects have in mind, they all focuses on the customers. So we are building something because customers want us to do something. And if we speak about customers, the first question is always, who is my customer? Do I really know my customer? And if I know who is my customer, do I really understand them? So this picture really shows about how can the conversation between customer, engineers, IT departments, coaches, and so on can happen. So when you have a look at the upper left corner, it's about what the customer explained. And maybe that's not what the customer wants, really. And then there are some steps about what others understood from what the customer told us. And the question is now, how can I get to know the requirements? So instead of just thinking, okay, the customer knows what he's telling us, he might just have not the right wording for us to really work on this, for example, investment project. And it's also on us to really question what the customer really needs. And on this picture here, you see on the upper left side what the customer explained, and on the down right part, what the customer really needed. So you see a slight difference. Of course, it's not really far away, but this slight difference leads to the fact that we always have kind of some interruptions within different kind of projects. So we try to focus here and really understand what the project is about. Now, as I mentioned, I will give you a short introduction. Of course, you are not an expert after that, but I hope that you get the understanding and the mindset of Lean and Six Sigma and what it is all about. So within Lean and Six Sigma, we have got a method which is called the DMake. So we have got 5 phases that lead us through our improvement projects. And it always starts with the define phase. So what is the problem we want to solve within our Lean and Six Sigma project? If that is defined, the customer is defined, we have got to understand what we do. We start then with a measure phase, which is the leading question is, how big is your problem? Sometimes it happens that somebody says that somebody told that we might have a problem. And the idea is not to belong to this gut feeling, but really use the data that is available or measure new data points to really understand how big is our problem. And sometimes it can happen that we see, well, we don't have any problem here, but we might have to look at another process. Then after the measurement and we found out that we have a problem, it's the analysis of that. So what are the key root causes? So not each and every root cause, but what are the key aspects that we can change to improve our process? Then after that, it's the improve phase. And the question here is, what are the best solutions? Also here again, there are many solutions around, And sometimes the first solution is the best solutions, but sometimes it's just not. So improve should make sure that we're taking really the best solution after evaluation. And the last part, which is sometimes forgotten, also really essential, is the control phase. So how do we ensure that the improvements are sustained? So after the project is closed, there should be some documentation and a handover so that the work we have done is not forgotten within a month, but that the knowledge is transferred into the daily life of this process. So this is really a general overview. And now if you dig a bit deeper into the phases, there are some leading aspects for each and every phase. And of course, also here, due to the time reason, I cannot just go into detail, but I took one tool for each phase, which I think can be helpful for you to really understand and maybe use it in your daily life. So as I mentioned, define, it's about understanding the business case. It's about understanding the problem. It's about not working or thinking in solutions, but understanding about the problem. And the first important thing is, if you work on a project, is that you understand what kind of process you are working on and what is the idea you have to improve. So there's one tool which I really think is really helpful for that. It's called SIPOC. And a SIPOC is a tool that gives you really high-level overview of the process. It's not going into detail, it's really high level. So this process starts with a supply, then which leads to an input, then the process starts and there's an output and of course a customer. The process should be divided into about 5 to 7 steps to describe what is happening there. For example, our supply can be that a customer orders a product from us. The input is then, of course, we need the invoice and we need raw materials. Then the process is, okay, we bring the raw materials together, we are mixing it, we are cleaning it up, we are filling it, and we are packaging it. And the output is the final product in the right package for our customer. So, of course, this is really high level, but if you're working in a team from different departments, it's essential to have this common understanding, because a lot of times I've seen in the past that people think that they have a common understanding of the process. But if you start with a SIPOC and the discussion started, it always derives that, well, we might have not the same understanding of the process. So SIPOC helps you really get this overview of the process, a common understanding, and also helping you of the scope of the project, what is in my project and what is out. So when that is done, and of course a lot of other things need to be done, the define phase is finished and we came up to the measure phase. And as I mentioned here, in measure, it's about data. If you can't measure it, how do you want to improve it? And of course, there's somehow trouble to get the data. You can use old historic data, but please make sure and use a validation step for that, because not all old historical data are really valid. Sometimes it's not just about doing statistical analysis. Sometimes it's about visualizing the process a bit deeper. So starting from the SIPOC, going a step further down and using, for example, this kind of swim lane diagram to really show what kind of departments are involved into that project. How is the process looking like? Do we have got matched circuits or it's going straight through? To really visualize it. It helps for a better understanding, and it's easier to identify if you see any kind of waste within this project. So measure, of course, if you've got data, use it, but don't forget also to use this visualization part of the process, how it looks like. So measure, we then identified, well, we really have a problem, which means our yield is too low, our timelines are too long. There are several different aspects that can derive. And the idea is now within the next phase, the analyze phase, to find the influencing factors. So what has an influence on our process? For example, in production areas, is the raw material an issue? Do we have got issues with the measurement system? Is the handling described properly, or do we have got to adjust the handling procedures? So there are many, many ideas. And how to really focus on that is also when you want to, for example, improve your timelines, it's a type of waste. And there's one good tool you can use within each and every process, which in each and every project, and I would also say within your daily life, the 7 types of waste. So it's called the STIMWOOD, and it's really focusing on what is within our project that it's not really adding value to it. So transport means how many things we have to transport from A to B. For example, raw material, transported from one part of the building to the next one and back again. It's about inventory and not about reducing it to the least minimum of it, but having the right inventory at the right place. It's about motion, how we as employees, for example, have to walk in a lab to find all the different things we need to do our reaction. It's about waiting. How long do we have to wait to get approval? How long do we have to wait until we can start with the next production step? How long do we have to wait until we get our quality control results? It's about overproduction, and that means, are we producing the amount the customer wants us to do? Or are we producing just more and filling into our stock? Or are we producing too less so that we cannot fulfill customer orders? Another aspect is the overprocessing, which means what should we really do within our process, and what is the customer asking us for, and what is just too much? Because, of course, we like to have some engineering add-ons, which are really nice, but they might not be increase efficiency within our process. And the last one, of course, the defects. If you produce something at the end where you just have to throw it away, the whole process was a type of waste. There are 2 further ones, utilities and skills. And skills, I would now focus on you, like what skills do you have and how can you use them? How can you improve the processes in your daily lives, in your projects, and make the most of it? So now, after the analysis, we came to the improved part. And for the improved part, it's about what I mentioned before, choosing the best solution. We tend to think in solutions. So we have got a problem and we are engineers, we want to implement a solution. Sometimes the first solution is the one, sometimes it's not. So the idea is to create a list of possible solutions and rank them, to compare the ideas and how they work on our key root causes and how do they fit to our business case. And the idea is also here to test your ideas as long as you can. Of course, if you're in a construction project, testing a new building, it's quite difficult. But also here, there are some ideas, and now referring also to the agile mindset, it's always possible to test your ideas when you try to do a pilot. You test it in a small scale, and you check the results with the things you want to solve, and you check it against what were the issues. And then you work on it into the next iterative steps. So we had a problem and we have a solution. Now we can tell, well, that's it, we are done. The problem is, if you're doing that, we are reinventing the wheels again and again and again. So the last phase is really essential, because at that phase, you create a reaction plan. So how do we react if something really goes wrong again? And it's also to make sure that everything is updated and that there's a basis of documentation which you can hand over. The worst thing you can do is just nothing. So no documentation, you're gone out of the project, and then the next project will start again and do the same thing like you have done. So the idea is to have this kind of lessons learned and continuously improving mindset by really making sure that you updated your procedure, you have got new SOPs, that the people who have to adapt to the new process are trained and they are explained what are the changes and how do they benefit from that. And that's the way how they accept the new process and stick to the new one, and not after you left the project, they stick to the old behaviors. And it's also a good idea to have some kind of visual management, which really shows then, okay, where is our process currently? In chemical reaction, for example, is the yield at the level we want to have it, or do we have to do any adjustments? Are we near the 100% goal, or are we going back again and need to recheck our improvements? So please take with you that if you are in a kind of Lean and Six Sigma improvement project, please do not skip the control phase, but use it as a lessons learned, and that the knowledge you earned during that project is transmitted to the younger generation. Now, of course, this is quite theoretically, and I thought of what kind of case studies I can show you. And of course, there are confidential reasons that's why I just took out the summary of the project. But the first project I brought with you, it's a stabilization of a production process. And this project just closed this week. I was coaching a green belt project, and the idea was here, the stabilization of the process, as I mentioned. So what was the problem? The problem was that we had low yields and a lot of process instability. So that was set. We want to have a goal which is higher than 85%. Well, so we started like, okay, we measure. How big is the problem? And we first had to identify process parameters that can help us to understand it, to really see why is the process unstable. And I didn't put the parameters here due to confidential reasons, but what I can tell you that we really had a look at the yields, and we have seen that the yields were between 18% and 81%. You see a really big range. That has been different products, but at this case, we have seen within the data, okay, Houston, we have a problem. So the next step was, okay, what are the key root causes? The first thing was to check the measuring systems, and we found out that we don't have any issue there. So there were rumors around that, of course, the measuring system is wrong. Well, it's not. But what we found out that we really see a high impact of the working procedures. So people have done it in a different kind of way, just slightly, but this slightly difference led to a really high variation. And we also have seen that raw material has got impact at this stage. So what were the best solutions? Of course, the first solution was, okay, we have to really do some standardizing procedures. And of course, you can't do that on your own. So in this case, the workers from the line were put together in a room for a complete day, and they were working on their processes and identified where there were differences and how could they standardize it. The raw material delivery had been changed to have it in smaller batches to increase the quality. And it was also said that this revision of production process has to be taken place not just once within the project, but it's now a regular establishment within every few months. The workers from the line come together and really recheck how is the process going and what needs to be adjusted. And how is it sustained right now? Well, there has been new SAP. The people are trained. The people are really motivated because they see their ideas are implemented and they see really the improvements. And from the last few batches, we have seen that our yield is constantly above this 85% goal, which is really good when you have a look at the 18% where we started for someone. So I think this shows how Lean and Six Sigma helps you to give a really structured approach. And I took a second case study, and this is also leading to the next topic I want to really shortly cover is about Lean and Six Sigma and Agile. So this is a project from 2018. It's about the expansion of the solving filling capacities. The problem was here that we had an increased demand and we had got capacity issues. And the goal was to optimize the process flow and, of course, increase some new capacity. So it really is a combination of Lean and Six Sigma, classical process improvement project, and a CapEx investment project. So what the people have done is they took the process mapping, so identify what is the process looking like. And from the agile mindset, from the design thinking, they did a lot of customer interviews to really understand what are the needs. What is the key of this project and what is needed? They identified the key ones and the issues, and they were working on pilots on that. And they're working on pilots using Lego. They're using 3D simulations, and they test these pilots with the customers and did a lot of iteratively steps at that point. And the control phase, of course, it's a quite bit different compared to classical Lean and Six Sigma projects, because in this case, it was about the construction. So the construction work was performed with the knowledge we had from the Lean and Six Sigma tools and technologies, and the new capacities are online and working fine. So what I did here right now is the combination of these two tools, and it's my last part I want to have shortly discussed with you. Lean and Six Sigma and Agile are different methods, and Agile, of course, is used as an umbrella. And I mentioned I don't want to go into detail here. And they have got different kind of focus areas. So Lean and Six Sigma are focusing on reducing defects and improving quality, where Agile is focusing on really on this flexibility and responsiveness to change. The methodology is both way it's structured. So there's no unstructured way to do it, but the structure is a bit different. So DMAIC goes from D to C, where you have got an Agile, it's iterative cycles and have a lot of customer review insights. Time frame, of course, is different. The DMAIC project lasts more than several months or sometimes years, where an Agile project tends to be a bit short of cycles. But the common understanding here is both focus on the customer. It's always a team collaboration, and both methods are used to improve our processes. So for me, these both tools are really helpful to go closely together. And now I'm at the end of my time, and I've got 3 key takeaways for you. So first one, Lean and Six Sigma focuses on improving efficiency and reducing waste. DMAIC is a structured process that helps you during your improvement processes. And of course, the combination of different tools is willing to the improvement of our processes. And the strength of both approaches together will help us in the future to structure and to really fulfill our customer needs. So with that, I'm at the end of my presentation, and of course would be happy to answer some questions. Thank you very much.
Thank you, Silvia, very much for the nice talk and perfect timing, actually. So that was probably Six Sigma. Of course, first, I want to look into the Q&A function, which every one of you should be able to use. We have a first comment here. I'm going to read it out. Great presentation, Silvia. Without any doubts, Lean and Six Sigma is one of the best tools for continual improvement and gives lots of learning opportunities. Can you share a few personal insights in how far it helps developing a personal career path? Awesome question. Let's see.
Yes, of course, happy to answer that question. For me, personally, it really shaped my career path, because Lean and Six Sigma is a basic tool and it can be used in different departments in different areas. So when I started my Lean and Six Sigma career, I was in quality and really using it for improving our processes. And now from that on, I moved to the engineering department, which at the first glance is not really comparable to each other. But also here within our engineering department, we have seen a lot of opportunities how we continuously can improve our lives. And this, of course, helps me personally, because I'm a bachelor from background, but working in an engineering department gave me a lot more insights and will then lead me to the fact where I'm now. So heading the department of project development, I would say wouldn't have been possible without these steps. And this Lean and Six Sigma methodology really opened this door for us, and for me especially, so that I could have a look at different departments. So for me, or an advice for you maybe would be to use this tool also as a door opener, and also to really increase your overview of what can we do. And it really allows you to enter in different departments you wouldn't have thought of at the beginning, but leads to really continuously also developing your personal skills and your career with new pathways you would never have thought of.
Mm-hmm. Great answer. Thank you. Also, maybe topic that if you face a problem, you know that there is a structured way to cope with it. So not being not able to do anything or feeling overwhelmed from it, right?
True.
Another question that I maybe have. So in projects, there often is not too much time, so you are very much in a hurry to get things done. So most of the time, the part where you define the beginning is very short. And then I always struggle yeah, okay, we should start with some experiments. We should start now doing that and that. And there's a lot of pressure to be very fast and things. So how can I make sure the define phase is long enough and not too long?
So as I mentioned, Lean and Six Sigma is focusing on the customer. You have to understand the customer and the scope of your project. Otherwise, you start doing your experiments, for example, and if it's not what you should have done, it's just all waste. So you have to think of everything I do without even knowing if that is the scope is total waste. So I would prefer spending a few more days, months, depending on the project, on really scoping the project and also go into discussion and using these iterative steps with the customer to really make sure that you understand it and explain to them that it's essential to really spending time on here, because otherwise, the later you are in the project, the more expensive it is to change something. The earlier you do it, the change, it's less expensive. So focus, of course, time pressure is always a topic, but focusing on really the first part, the define and measure part, really helps you to be fast at the end, honestly. So if you understand the customer needs and wishes and understand what you should do at the beginning, you are fast at the end. But of course, this is some kind of a mindset change, I have to admit, which you and the sponsor needs to accept, that spending more time at the beginning will help us on the overall time. But I'm a big fan from it, and I would also ever argue with the sponsor that if it's not clear what I should do and that the scope of the project is not clear, well, you can't just proceed.
Yeah, I agree. Thank you for answering that. More questions from the audience, not right now, but please feel free to post them in the Q&A. So maybe one last short question. I know that you, Silvia, have to leave soon. How long is the training to become a Lean and Six Sigma professional?
Depending on the color of your belt. So my Lean and Six Sigma green belt training, it was about 2 weeks training, but honestly, it's not just the training, but the usage of the tools in a real project. I would say is also the big important thing here. So theoretically, practice, of course, but bringing that to a real project and using theory to practice, you have to do it. Otherwise, you're just a trained green belt without really adapting these methods. And if you then go from green to black, it's additional 2 weeks. And to master black belt, it was also additional 2 weeks. So in summary, for me, it was now 6 weeks, 7 weeks, depending on the timing of training.
Okay, and then ongoing.
And then continuously using that and try to implement the strategy approach of that also within different kind of areas.
Okay, great. Thank you. So hopefully everyone can get back to your inputs and insights. Thank you very much, Silvia, for the talk.
Thank you, Silvia.
I'm going to hand over to our second talk. The speaker is Dr. Jamie Cleaver, and the talk's name is Engineers Communicating for Fun and Profit. Sounds good to me. So welcome to the stage, Jamie. And please feel free to share your screen as soon as you like.
Yeah, let me share my screen. Okay, here we go.
And then.
So, right. I'm hoping that you can see my screen now. No,
not
you can't.
Yet.
Not yet. Let's try again. Okay, I've got to go like that. There we go. Hey.
There we go.
That works. Fantastic.
Great.
Good. All right. Thank you. Silvie, thank you very much. And Silvia, thank you very much for the presentation on Lean and Six Sigma. I learned some stuff there. So that was great. Thank you. Welcome, everybody. Welcome to this presentation on engineers communicating for fun and profit. So this is one of my favourite subjects, and it's a pleasure to be able to bring you some thoughts on this. I'll say a few words about myself first, just so you know who's talking to you. So I'm a chemical engineer by definition. I studied chemical engineering, and I work as a chemical engineer. I've got industrial experience, commercial experience as a chemical engineer. I also lectured chemical engineering in academia, doing research and teaching at the University of Surrey here in the UK. I did that for 16 years, and in 2010 I made a change, and I now work for myself. I work freelance, and I really love what I do. I do a lot of training work, and the training work I do is it got two sort of strands to it. The first strand is essentially technical chemical engineering. And one of my key themes is helping people develop scale-up strategies. So I spend a lot of time working with chemical engineers and discussing and training the concepts of process scale-up to help people develop a scale-up strategy for their specific process. The other thing I do technically is to help non-chemical engineers understand and appreciate aspects of chemical engineering. The other side of my training work is around communication for people with technical backgrounds. And I first became interested in this when I was lecturing as an academic at the University of Surrey. And one of my roles was as a tutor who helped students find placements in industry for their year of work experience. And so I was acting as a broker between the students and the organizations, the companies. And I could see that the skills that the students had to offer, and I could see the skills that were required by industry. And there was a big gap there. And most of the skills related to communication. And I can see there's quite a demand for communication skills, particularly among technical professionals. Anyhow, that's the background for me. I'm just looking to see if there's anything I needed else to say, but I don't think so. I think what we'll do is to proceed with the presentation and see where this takes us. Okay, so activating my slide deck. Let's start with a story. The sad story of the Mars Climate Orbiter. So here it goes. 11th December 1998. The Mars Climate Orbiter blasted off to go and orbit Mars and to explore the Martian climate. It entered into orbit around Mars on the 23rd of September 1999. Radio contact was lost. What actually happened? So the Lockheed software calculated thruster impulse in units of pound-foot-seconds. You know where this is going, don't you? The data were fed to NASA software to calculate the position for the spacecraft, assuming SI units of Newton seconds. There's a factor of 4.45 difference. The spacecraft entered Mars' atmosphere at an estimated height of 35 miles, rather than the intended 68 miles. So the spacecraft was lost. It was unmanned, of course. However, a big mistake. And the mistake was not from a technical standpoint. Everybody knows from the first semester of an engineering degree or before about converting units. The problem was a communication problem. So this is quite an extreme example of poor communication causing problems, loss, damage in an engineering project. And I'm sure that you've heard of or have experienced firsthand other examples where there's been, due to a poor communication or misunderstanding, there have been problems with an engineering project. Okay, so now we've had a quick look at an example, a story. At the moment, we're aimless. What does that mean? We need a name. And let's have a name for what we're doing today. And let's have a name which says we're going to help you identify the main challenges and fundamental concepts of communication and to consider how you might develop your skills. Notice this is a presentation about communication skills. And what we're doing here is saying, okay, well, when we're going to communicate something, we really ought to have a name. What are we trying to achieve with this communication? Because if we don't have a name, we're aimless. The other thing that you need, if you haven't got it already, and I'm sure you have, you need a notepad and pen. All right. So maybe you're scrabbling around to find a notepad and pen, or maybe you're good to go. Is this man communicating? 1, yes, effectively. 2, yes, but not effectively. Or 3, no. All right. So if we were in the same room, same space, you'd be putting your hands up and or shouting out answers. And we could say, well, maybe shouting through a megaphone is not effective, or maybe it is effective, but whatever you're doing, not effective. Why is it not effective? He's actually not communicating. He's not communicating because in order to communicate, you've got to have transmission and reception. In other words, 2 monologues do not make a dialogue. So there's a quote from Jeff Daly, an architect. So we've got this idea that communicating is not just transmitting something. It's about what you've transmitted, either by writing or by speaking. It's actually getting received. Okay, so that's the first important thing. So we're going to be looking at some fundamentals as we go through, fundamentals about communication. And as we go through, we'll then look at how we might learn what we can learn from this. Let's say a little bit more about communication for engineers. All right, so Dale Carnegie, he's written a few famous books. One book is How to Win Friends and Influence People. And his take on this is, even in such technical lines as engineering, about 15% of one's financial success is due to one's technical knowledge, and about 85% is due to skill in human engineering, personality, and the ability to lead people. Okay, that was the phrasing he used back then. I think we can really summarize this as being related to communication, the ability to communicate. Einstein is a rich source of quotations. If you can't communicate it simply, you don't understand it well enough. So I quite like that quote as well. But there are many, and we could have filled the whole session today with Einstein quotes because they're very, very profound. Right, let's dig a bit deeper into the expectations on engineers for good communication. In the UK, in the United Kingdom, there is a document called the UK Standard Professional Engineering Competence and Commitment document. It's the UK spec that says, if you're a professional engineer, if you're going to become a chartered engineer, which a lot of early career professionals are aspiring to, then this is what good looks like. This is what we expect of you. So there's a chartered engineering standard, which contains a certain level of knowledge and understanding, a certain experience in design, development, and solving engineering problems, a certain amount of responsibility, management, and leadership, communication and interpersonal skills, and personal and professional commitment. Let's have a little look at what's in this box here about communication and interpersonal skills. By the way, this is what's required in the UK to become a chartered engineer. We're expected to be able to communicate effectively with others at all levels in English. Clearly present and discuss proposals, justifications, and conclusions. Demonstrate personal and social skills, awareness of diversity and inclusion issues, knowledge and managing own emotions, strengths, and weaknesses. Okay, this is what's required. So it's an expectation. It's not something that's an option or an add-on. It's not, if you want to be a professional engineer in the UK, this is what you have to do. All right, let's have a look at the European side of things. The Euro-Ing spec. It comes from this standard, the Euro-Ing spec professional engineering competence. And similarly, there's a whole list of competencies. Let's have a look at the professional competencies around transferable skills, which is specified in this document. First of all, an ability to work with others on multidisciplinary projects. Well, that will involve communication. It's multidisciplinary work is often more challenging than working with people in the same discipline. an ability to provide leadership, embracing managerial, technical, financial, and human considerations all around communication, because without communication, none of this is happening. Communication skills and an obligation to maintain competence by continuous professional development. That's interesting. So this idea of it's not just a question of, oh, communications tick, it's sorted. It's, oh no, communication skills, how can we keep getting better at it? Continuous professional development. And then fluency in European languages sufficient to facilitate communication when working throughout Europe. So I really respect you guys because you're working in my native language today. And I'm in awe of you because I couldn't work in your native language. So I think that's really impressive. So this is what's required if we were expecting to be professional engineers. It's not non-negotiable. We need to be working at our communication skills. Okay, how do we get into the position of being relatively poor communicators compared to other people? And I think this is true. Engineers have got a pretty sort of poor reputation for communication generally. Let's look at how our education looks for people that have gone through science and engineering studies. We tend to be problem solving in isolation. Yeah, there's group work, but it's relatively small. We've got worksheets to go through. The work is often solitary, and we're learning how to solve problems, learning the mechanisms, learning the fundamentals. Whereas humanities students, they'll have a lecture where they're introduced to concepts, and then in the timetable there will be seminars where they sit around and discuss and listen to each other, debate. So communication is hardwired into the education of humanities students, and it's hardwired out of the education for technical students comparatively. Okay, so this means that when engineers go out into industry and we're interacting with all sorts of people, we are interacting with other engineers, of course, and we're also interacting with people who have got a humanities background, whose communication skills blows us out of the water. Right? So we've got a bit of a mountain to climb. Anyhow, let's look at the big picture. The big picture, engineering communication. Here we are starting at this box here. And we can think about our communication challenges in terms of where we've got spontaneous communication in meetings and discussions. Or we could come down here and we could think, okay, we've got some communication to do and we can plan it in terms of writing an email or making a presentation or preparing a report, for example. Whereas on the spontaneous sort of discursive sort of areas, aspects of teamwork or problem solving or collaboration or feedback. So a lot of the things that Silvia was talking about earlier would have involved communication, which was spontaneous, resolving conflicts. Networking is often a challenge. So get your notepad and pen out. What are your communication challenges? So this isn't a complete list, obviously. This is just some typical examples. And we're just giving you an opportunity to articulate what you feel are your communication challenges. Okay, that's the big picture. Let's move on and talk about empathy. Empathy is the key to effective communication. There's you sitting at your 1990s style workstation, and you're writing a report for a reader, could be a client, could be a boss. What we're trying to do in empathy is to build a bridge so that you can convey what you want to say to the reader in an optimized way. More formally, what do we mean by empathy? It's the ability to put ourselves into the mental shoes of another person, to understand their emotions and feelings and expectations. This comes from Alvin Goldman. And the same thing would be true if two people are having a conversation, and in order to get the best out of this conversation, it helps if both people can operate in a state of empathy where they are anticipating or predicting or reading the emotions and feelings of the other person. Why is this important? Well, communication doesn't just contain facts. Facts contain or are involved in emotional content as well. It's important that we're able not only to put ourselves into the mental shoes of another person, but we're able to self-empathize. That's to understand our own emotions and feelings. And how do we empathize? Well, we can empathize when we're face-to-face with people by listening carefully and by reading body language. Okay, so that's the empathy side of things. Empathy exercise, we're a bit short on time, but we could think about, well, you normally have a good working relationship with your boss. However, one morning he comes into the office in a bad mood. He calls you into his office and criticizes the structure of one of your reports, even though you thought the structure was agreed with him last week. So how do you feel? What do you do? Well, first of all, you probably feel quite cross. So maybe you stand your ground and you give back as good as you can get. In other words, you have an argument with him. Maybe you decide, well, I'm going to agree with him to avoid a scene, even though I know I'm in the right. Or you take his point and go, okay, I know what you say, then let's meet later and we'll talk through it. Okay, so we can think about which one we would do. Probably having an argument is not the best course of action. Giving in is probably not the right course of action. It depends. It depends on your relationship with your boss, of course. But actually connecting with him and also connecting with yourself and going, oh, this has triggered me. I'm in a bad mood as well. Dealing with that, and so that you self-empathize. What's going on for me? Deal with it, and then what's going on for my boss? He's in a bit of a bad mood. I'll catch him later and sort it out. So there we go. Let's talk a little bit about listening, because listening is one of the ways we can learn to empathize. How do we feel when someone listens to us? When we listen to, it's a bit weird. Like, oh, someone's listening to me. This person's actually interested in what I've got to say. Sometimes that's quite rare. We tend to feel valued, appreciated, unrushed. It can help us be creative. How do we feel when we're not listened to? Well, it's frustrating. We feel unappreciated, feel unimportant, maybe angry, disengaged. So this is useful in itself. Just by listening to people, we can make them feel valued, appreciated, unrushed, and creative. And if we actually demonstrate to people that we're not listening to them, this is how we make them feel. This is really useful if you're in a position of going into leadership. Because if you're leading people, you want people around you to feel valued, appreciated, unrushed, and creative. So this is useful information. Plus, when we do listen to people, we get a much richer data set on what's going on for them. We're very good at diagnostic listening. As engineers, we listen to the facts, so we start diagnosing, what's relevant, what's irrelevant, what's right, what's wrong. We start listening selectively and developing a hypothesis, and then we say, okay, we diagnose and respond with a solution. Not usually, well, it serves us well sometimes in the technical side of things, but it's not particularly useful, and sometimes it doesn't help us get the best out of the situation. Active listening, on the other hand, we're not listening to the facts, we're listening to the person, encouraging the person to think openly, and we're finding out more information. We're really hearing in detail and reflecting back our understanding, and then we respond in more of a considered way. We can do better than that. We can do something called empathetic listening, which is not listening to the person, it's listening for the person. You're creating space for that person to speak and to think into. Helps us understand facts and emotions. We temporarily put ourselves to one side, focus on the speaker. It requires us to be genuine. It requires us not to judge, because if we come across as being not genuine, or we come across as judgmental, then that tends to close things down. If we advise, that tends to not go well either. And we're probably not the expert on that person or that situation. So this concept of empathetic listening comes from Stephen Covey, who's written a very famous book called 7 Habits of Highly Effective People. Seek first to understand and then be understood. So there we go. Let's talk about body language. 50% of personal communication is non-verbal, apparently. So these two chaps are having a conversation. We can see their bodies are in different positions. We can think about what's going on for each of them. This chap over here looks very relaxed. This chap over here quite thoughtful. So what kind of thing is body language? How people sit, the space between people, the expressions on their faces, to what extent they might make eye contact, how they move their arms and hands. And body language helps reveal the emotional component of communication. It's key. Often you see pictures of body language, like we've got this picture here of a static position. So this chap posing like this with his hand on his chin. Oh, he's obviously thinking. Maybe not. What's most useful, much more powerful, is looking for the shift in body language, the dynamics, and as a response to a change of topic or someone else coming into the room, something like that. Look for the dynamics. Learn to read body language and learn to speak body language. This is a powerful sort of area to move into. So we're closing off some fundamentals around communication. Communication efficiency. What percentage of information do you think is typically retained by an audience member? And this is a question for you guys. Write a number on your bit of paper. If someone's making a presentation, blah, 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 60%, blah, 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 whatever. And people are often not concentrating or going to sleep. So when I ask this question to people, I get a number that maybe between 5% and 30%. Both of those are even 30% is unacceptable, really. So we could think about, well, whatever percentage I put, and usually it's that kind of number, 5 to 30%. What can you do to increase that percentage retention? So this leads us to this idea of the Shannon and Weaver model. Shannon and Weaver model was developed by Claude Shannon and somebody Weaver, and they worked for Bell Laboratories in the United States. And their model is being described as the mother of all models, and it's a mathematical model. It's very technical. You can see we've got some kind of signal processing stream here. Some input facts goes in here and comes out as a sort of jumble, and there's the letter A is missing and things are distorted and in the wrong order. So there's some kind of loss of integrity along here. And we can think about this in the context of making a presentation, perhaps. We've got a presenter, there's a channel, and we've got the audience there. Noise is anything that's competing for the signal. So let's have a look at what's in the encoding box up here. What's in the encoding box? The presenter can't say everything, but he's got to package it and express it in a way that makes sense. The presenter's own emotional preferences and levels of understanding are going to influence the compilation of that information. What's the noise? The noise is anything that competes for the information. The channel, by the way, would be the room, the space, or the computer space if it's an online presentation like this. So the noise is anything that competes for the attention of the listener. So poor slides, distractions, Wi-Fi dropping in and out, poor presentation skills. What's in the decoding box? Well, similarly, this is really how the audience members make sense of the information, and they're going to make sense of it and recall things that they prefer, maybe they have an emotional connection with. They're going to understand things, retain things that they understand. And then there's a feedback mechanism. We think about, well, how that feedback mechanism might work. The original Shannon and Weaver model didn't involve a feedback mechanism, but this idea of confirming understanding. So this is useful. What it helps us to do is to think about any communication, whether we're making a presentation, writing a report, or having a conversation with people. We've got something to say, and we encode it in some sort of way which hopefully is optimized, goes through some channel. We try to minimize the noise, and goes through, we have to understand that there's going to be some kind of decoding process, that they may not fully understand what we say, even though they say they've understood it. So we ought to get some confirmation. So we might plan what we say, deliver it clear, concise and confidently, and then having some follow-up to understand the level of understanding. Okay, Look, I'm looking at the time, and I'm conscious that we are getting towards the end of the session. I just want to talk to you about the differences between people. And this is, for me, was quite a profound thing, where sometimes I'd have a conversation with someone and it just wouldn't work. Not that we'd end up having a fight, but it was just things. We left having the conversation with different understandings, or we just didn't click. And why is that? Well, people are wired differently. And if we're aware of the differences between ourselves and others, we can get the best out of the communication. So this is the idea behind this. Understanding differences goes back a long way. Right? So we've got really BC dates where people were, Plato, were looking at different classes. And they seem to all become in 4 different classes. Myers-Briggs is quite a popular one. And many of you will have come across Myers-Briggs. There are some others. The one I particularly like is this one. However, all of these are good, and that there's no right or wrong here. It just gives you a framework for the concept that people are wired differently. The reason I like this, let me go back a minute. The reason I like this social styles model is because it is based on not on psychology, what's in the pie. It's based on what you can see on the outside of the pie. It's based on observable behavior. And what do we mean by observable behavior? If you followed someone around with a clipboard and observed their communication, you would find that some people were more quiet or were louder, slower paced or faster paced, more casual, more rigid, made less eye contact or more eye contact. There's no right or wrong here. It's just, this is what you might observe. And this is based on, this is the original reference for Merrill and Reed, Personal Styles and Effective Performance. And of course, what this leads to is just 4 types of behavior: the driver style, an expressive style, an amiable style, and an analytical style, based on 2 statistically independent axes. And the left right axis, this is whether people would assert themselves by telling, come on, let's go for lunch, or asking, should we go for lunch now? Or on the vertical axis here, less responsive and more less expressive, and down here, more responsive and openly expressive. So the challenge, of course, is, by the way, everyone has a preference, or everyone tends to fall into one of these categories. And knowing where you are, so let's say I'm down here, because I am, this is my box here. So I'm slower pace, focus on relationships, I'm casual and informal. And if I have to work with someone who's at a driving style, or communicate with someone at a driving style, we are at opposite ends of the spectrum. And so because they're faster pace, they are much more goal focused and task focused and more serious and formal. So I have problems talking to this kind of person. So that means knowing that I had to adjust my style to accommodate. Similarly, basically there are pros and cons with operating with any particular style. So over the analytical style, a lot of technical people fall in this place where they're focusing on the detail, and they would have problems operating over here and having a conversation with someone who's an expressive style. So people are different. Let's finish with this concept now about the big picture. This is what we've said. We've talked about empathy. We've talked about communication efficiency. We've talked about mentioned planning, delivery, and confirmation. And we've just talked about the fact that people are different. So what are you taking away from this? Right? We've laid some foundations here. I'd encourage you to make a note of things that that resonate with you. The other thing I want to mention is, well, what's next? What haven't we talked about? Being assertive. That's a skill we can learn. Being respectful and being genuine. Because being respectful and genuine, coupled with empathy, are platforms for establishing trust. And trust goes a long way when it comes to working with people and communicating. Other things we haven't talked about, different styles and audiences. So if I'm communicating to a group of 15-year-olds doing outreach for engineering, my style is going to be very different than if I'm talking to a group of PhD students, or you can understand that there are times where you have to adapt your style, and that's a challenge. How do we learn? We learn by action and reflection. You can't theorize this stuff. You learn by action and reflection. So, final slide. This was the title. Profit. Hopefully you get this. Profit, if we're good at communicating, things are more effective. Our collaborations work smoothly. We can transmit information more effectively. And that's going to translate into the bottom line. Where's the fun here? What's that word doing? This is the point I want to leave you with. If you're not enjoying what you're doing, when you're communicating it, it's going to come across. If you're feeling bored by the subject you're working on, or if you're feeling miserable about it, unhappy about it, then that's going to come across in how you write, or how you speak, or how you present it. So dialing in the fun is essential for good communication, and it's enjoyable. Okay, thank you very much. I'll stop there.
Thank you very much. I totally agree, especially to the last thing you said, 100% with you. It should be fun. Okay, looking at the time, we have 2 questions in the Q&A. The first one is fun and profit just, and why not future and sustainability? This is kind of
so fun and profit, yes. Why? So, and was it future and sustainability? Was that the question?
Yeah.
Yeah.
Why not future and sustainability?
Why not? Well, it's a title, and the title is supposed to be provocative, so we provoked, which is good. And of course, if we think about what profit means, any organization that is in business for the long term, which you should be, is looking towards the future and is looking to be sustainable. So I can't see a distinction between profit and sustainability and future.
Yeah, it comes natural with it if it's.
I can't see a distinction, because if you are operating without a view for sustainability and without a view for the future, you will not be profitable.
Yeah, maybe it was a provocative question to the provocative.
It was, yeah, I love it. This is cool, really cool.
Okay, second question. Hi, thanks for the presentation. My question is, how can I express my opinion or ideas in a work environment as a trainee or junior? Basically, how do I approach starting to also be a speaker and not just active, empathic listener?
Yeah, indeed.
Yeah, to make their voice heard more.
Yeah, great question. Great question. Indeed. So I think there's a lot we could say here. And the things that come into my mind are look for opportunities to communicate, think carefully before you communicate, and just looking for opportunities and start small. And looking for opportunities to say, making a short presentation or summarizing things in meetings. That's often a good sort of safe place to start with, where you're with your team and you maybe offer to give a summary or a review, or to something that you can bring, some information you can bring from a previous project. And say, maybe it's useful if I summarize this, and just look for opportunities. It's about, do you develop these skills by practice? So start small, and then try to do it as frequently as you can. And every time you do it, reflect, because the way we learn this sort of information, this sort of skill, is by doing it, yes, but then reflecting on it and go, okay, what could I have done differently? Or even better, have a conversation with someone and say, what did you observe? What could you suggest I try doing differently to get a better result? What could I do less of? What could I do more of? And then your trajectory for development is less like this, and it's more like that when you start reflecting on it.
Also, maybe, what do you think if one would approach the organizer of a meeting and then say, maybe could you hand over the word to me and this and that situation, or could you look my speaking time to be more relevant? Is this a method that would work?
Yeah, I think so. It depends on the situation and what's appropriate. But if you're keen to develop your skills, then particularly your speaking skills, often people are very keen to encourage people to give presentations. And usually it's the opposite way around. It's difficult to get people to volunteer, and people are going, "Oh, come on, please give a presentation," and people put it off and say, "Oh, I'll do it maybe next week." Well, no, do it today. So looking for opportunities, volunteering, making yourself available at every opportunity would be the way forward here.
Good. Thank you. Thank you so much. So looking at the time, we are a bit overdue and going to the next talk. No worries. So thanks again for being here. And now I'm calling Anne to the stage. We have talk number 3, which is about design thinking. Hi. So feel free to share your screen if you like to go ahead already.
Yeah.
And then we can see and hear you. And yeah, the stage is yours.
Thank you. Can you see my presentation?
Yes, it's in presentation mode.
Perfect. Awesome. Thank you so much for having me. And hi, everyone. I'm actually quite happy to be the third one because it builds up so nicely on what Silvia and Jamie just mentioned. And I'm going to try to utilize this a little bit as well for my presentation. Before I'm going to go into design thinking and talk more specifically about the process, the method, and the mindset, I would just like to introduce myself as well so that you know who's talking in front of you. I'm 31 years old, and I'm a German Persian who has lived in a lot of different places already, and a very passionate activist. And one important part of why I'm doing this also today, but in general, is that I really enjoy helping people develop skills and drive positive developments in organizations, as well as when it comes to personal development. A couple of milestones that I'm happy to share is that part of me being a passionate activist is that I'm very active in different boards and a board member of different NGOs. By training, I'm a biologist, and I did my PhD in cancer biology at the University of Copenhagen at the Center for Protein Research, and finished last year. During that time, I was also a co-founder of a grassroots initiative called CPR Goes Green, and we organized different symposia and built up a green sustainability network in Denmark, engaging more wet labs into the certification process of LEAF, for example, but also just making people aware about their footprint and how to improve this. Besides that, I'm still active volunteer with an organization that is called Vores Asylbørn that focuses on asylum-seeking children and supporting them during the process of applying for asylum. And since this year, I've started working for and with Likeminds, and still continuously trying to develop new skills. So based on all of this, last year I had to make the choice if I'm going to stay in academia and continue with a postdoc, or if I'm going to start to continue a follow-up on a couple of other things that I really enjoy. And that's why I ended up working with Likeminds, a small company in Darmstadt that focuses on big transformation processes. And we're, for example, also working together with Merck and other big companies and trying to support them in different parts of transformation process or change management components, as well as helping them in establishing tools like design thinking, for example, in-house, and enabling them to develop certain skills. And this is also why I'm here today, and why I'm going to talk about design thinking. And the beauty of this is that Silvia already mentioned a couple of components. What I just would like to start out with is that if you would, for example, Google design thinking, or if you look it up on Wikipedia, you will find a very generic sentence like this, stating that it's an approach to find new and innovative solutions to a problem, which is true. But I think there are a lot of buzzwords in this and around this whole field of agile work environment that sometimes can feel a bit overwhelming because it's not as specific as one as a scientist maybe like it to be. So what I would like to talk with you about today is what the approach actually involves, what innovative means, and what kind of problems it can address. And of course, also in context of the Flash Talk series here, why this is something that is interesting to further investigate for you in an early career stage. Let's dive into this. So the design thinking component itself is something that was developed in the 60s based on a research question of a psychologist wondering how designers actually think and what the process is that is needed behind a very creative way of generating new ideas. And through that, this design component was brought together with the thinking component, basically trying to do this with the more analytic part of the industrial components. And it is based or rooted in actually three big parts. So one is the mindset part. And this includes, first of all, the desire to understand the user. And I loved that Jamie, for example, talked about empathetic listening and active listening, because this goes very much into the first component, as well as the fact that you're stronger when working within a team, and that the if is something that is not as important, but the how. So starting to think more in options and not so much in black and white setups. And then, of course, the strong desire to continuously learn something new or change something, and generating tangible ideas. And this is a mindset that is something that I would say, based on my own personal experience, isn't very much trained within the academic context, also during your PhD, because the if, for example, is something that is a continuous component of every PhD project. And often ends up, maybe also as a hindering part of continuously developing or further develop your project. Design thinking itself can be seen as a toolbox or as a toolkit. So the idea is that it's something that helps to implement the mindset that I was just talking about. But it's also a toolbox that contains a lot of different things for different contexts and goals. But I'm not going to dive into all the methods that are part of the design thinking process. I just would like you today to get a broad understanding of what it actually means. Excuse me. There are different analysis components that are called, for example, 5 whys, or how might we questions, and core issue analysis, and so on, that are all part of the design thinking process. But in general, it is just a way of generating novel ideas. The process itself, and for me, this is of course something that was super exciting to learn more about, is a scientifically based process. So there has been many studies, also an institute that was developed based on the method close to Berlin, that is focusing on how this tool or toolbox can be further developed, and how it actually generated more innovative and novel ideas compared to the standardized or more normal process that was established in different companies beforehand. And this is something that is, of course, quite fascinating, because it's the same type of people, but just using a different tool set to develop something new, which I think is interesting to follow up on. Now, there are a lot of different principles, and I'm just gonna open them up to show you all of them. The important or the most important part for me in this is that you get a bit of an insight into what is incorporated when it comes to the mindset and the whole idea about design thinking. Part of it is that you're working human-centered, and Silvia has mentioned this earlier today already as well. And then the fail early, learn early component, so being able to kill someone's darling, for example, in an early stage, or also to work with time boxing or the Pareto principles. That means that you don't waste too much time, you just work with whatever you have there. And I think this is something that makes it a lot easier and takes a lot of responsibility from you when you just try to come up with something novel and a new approach, also for a project, even for a PhD project, for example. There is something called the safe enough to try moment, which is also called set moment, which is essential in the whole process, that you don't try to build something that is perfect. You just try something or utilize something that is safe enough to try, and then see where this is gonna bring you. And the other one that I would just like to highlight is the be wild part. And the realisticness behind it is gonna happen on its own, because this is also something I feel that researchers and engineers are not very well trained in letting go, because we tend to always check and factor in if it's realistic to actually go on with an idea, instead of first of all trying to just focus on the idea itself, and then the realistic part is going to happen on its own afterwards. Now, before showing you how design thinking works, I would just like to mention what an innovation is. And I think this is something that I hope that you can afterwards utilize in every other component of your life as well. An innovation usually contains three components. So the desirability, the feasibility, and the economic viability. And the spot in the middle where all those three align is the so-called innovative sweet spot. And this is what you're trying to hit with a new idea. And if you have an innovative idea for your own personal life, for example, maybe it's a new way of structuring your daily life, might be an innovation for yourself, and you can just have a look at the diagram or think about those three components to see if this is something new and novel for you to try, because then it's definitely worth giving it a try. Or if it's something that is maybe not on the economic viability part, and then not worth going for. So I feel like this is a super nice and very simple checklist just to have an idea of what an innovation could look like. But of course, in the company context, this is even bigger and more complex to see how this how an idea can become something more realistic in the end of the day. Now, so the design thinking process itself is based on 5 or 6, depending on who you're talking to, different key components, but those 5 are always the same. You have the empathize phase, the define phase, an ideate phase, prototyping, and testing. What does this mean now? In the beginning, you have the component where you understand the problem, and it's just like Silvia and Jamie mentioned today, human-centered. So trying really to get a real understanding of what the problem is and what the core issue is of the target group, which means that you're trying to understand the emotions, the needs, everything that goes along with it, and not just try to assume based on what you hear, because often the problem might be just a symptom of the core issue, which goes into the second component, so identifying the core issue and trying to utilize a lot of time to deeply dive into what the core issue component could be. Then generating a lot of ideas, and there the quantity matters, not so much the quality, and going over into continuing with a few ideas to then basically focus more on the quality of a few novel steps. And finally, testing and iterate to generate a tailored solution that actually hits this innovation sweet spot. Now, if you look at this, and as I told you before, this is something that comes from the design community, basically. There is a model that can nicely elaborate a little bit on how the process itself works, and how you can utilize this also in your daily projects, or even in a broader setup with an interdisciplinary team, is the so-called double diamond, which incorporates the problem space and the solution space. And the problem space usually starts with obviously a problem, but also generates a lot of space in which you can try to understand the core issue by really picking up a lot of different things that you feel like could be the problem, and then focusing on one component of this to be able to address this one component. So it then ends up again trying to narrow all the things that you have in mind and generate or start to come to the solution space in which you again try to find a broad range of solutions to this one core issue that you've identified, to then follow up with one more again. So again, here, if you look at those 5 steps, you can nicely fit them into the part of trying to really understand the problem and broaden up your horizon basically into what it could be, identifying the core issue, and then working with this core issue to continue trying to generate a lot of ideas, following up on only a few, and then doing a test with one tailored idea. Now, the design thinking process itself, as I have been, or as I'm showing you this here now, is something that looks quite linear. But in principle, and this is why it comes also from the agile framework and new work component, is that the idea is that you have many, many iterations in between and feedback loops. And I think, at least for me, during my PhD, I always try to have, the results done more or less, have a nice graph to prepare and show my colleagues to then discuss how to proceed after that maybe. But the idea in this setup is to do this much earlier, maybe using just the Western blot as it is, discuss this in an earlier stage so that you're faster in actually maneuvering through different problems that you're facing, but also to incorporate more feedback and maybe identify the core issue much earlier than what you're used to. So this process is something that is contains a lot of iterations and is supposed to happen in increments. Now, to follow up on this, the idea is to use time boxing as a way of just trying to come up with stuff quick and fast, trying to find solutions to the core issue, but also getting a good understanding of where you have the chance to go to a set moment, to a safe enough to try moment, and not try to be perfectionist in every step of the way, because maybe there is no chance to actually get to that point based on the feedback loops that you're doing. And then one important part is that if making a decision in that setup is extremely difficult, it might be actually a sign that you're missing some information and should step back in one of the phases to actually, maybe while you're in the ideate phase and you realize it's so difficult to come up with ideas, you actually need to go back to the define phase to really see and talk to your client, for example, if you have defined the right core issue, or if there is something in the empathize phase that you should actually incorporate and you realize that this is missing. So it's, for me at least, it takes a lot of responsibility. Again, it makes it easy to try to find a solution because you have something that gives you a bit of a navigation system through the process that can be very overwhelming and complex. The process that I've shown you here is a microprocess. So this is something that feels, I think, very intuitive. Now the question is, why isn't this something that every company does for every problem that they are having in every sort of situation? And the answer to that is that in reality, the process of this looks much more like this. You have a phase in which you have a more divergent setup of ideas, and over time you realize that maybe you're moving a little bit away from the starting point, and then you have the phase that is actually bringing you to the innovative solution. But all of this takes quite some time, even though you're using maybe restricted time measures, or you're trying to focus on certain aspects of this. But it is something that needs capacity, and you need to be able to actually follow up on this to go from A to B within the full circle of the design thinking process. And this is then, in the end of the day, the macro process that does take capacity, funding, and also energy of people to work actually in an interdisciplinary team and trying to build up on one another. Now, what I want to show you is just a very nice example of how the agile approach works, more or less. And I think this picture is such a nice way to highlight all the things that can go wrong, more or less, if you don't have iterative or increments in which you're working with the people that you're focusing on, so your target group, basically. In this case, it's a pocket knife, and maybe the person in the interview realized while talking that, excuse me, that they would also like to have 5 million other options incorporated into the pocket knife. And what the designers ended up doing is generating, in collaboration with some other team members, something that looks maybe like this in the picture, that can do basically everything, but doesn't meet the necessary needs anymore of being a pocket knife, because you need a full-on bag to carry this around, because the core issue wasn't really understood, and has brought up other issues along the way that weren't actually incorporated, or there was no feedback loop done, more or less, to incorporate the customer's needs or the client's needs. And I just like this because it's a nice visual to show how linear processes that are usually standardized in most of the big companies and organizations are working at the moment with different parts of generating new ideas. The same goes for this very old picture. I still love it. That's why I'm still showing it. But this is, of course, nothing that looks like this anymore. But for everyone who is in my age or maybe older, they will remember that back in the days, this was at some point the user interface when you opened Microsoft Word and wanted to write something, or at least components of it. And here you can again see that maybe there were a lot of great ideas and fantastic solutions, but the real problem, or the real reason what the target group actually wanted to do, was just writing digitally as easy as possible and as accessible as possible for a broad range of people. And having all those windows open ends up just complicating the setup. So in the end of the day, and now if you think about how Microsoft Office looks like now, is something where you can still have all of those fantastic options and features, but you don't necessarily need it just to write the letter that you actually want to write. And this is again a way of illustrating how if you don't have a lot of feedback loops and incorporate the needs and the human-centered approach into what you're doing, then maybe you will have a product that is not really useful in the end of the day for the actual target group that you were supposed to design this for. Last but not least, I would just like to share one beautiful example of how design thinking generated a very novel idea of first aid setup, in which the problem was that in rural areas where there's no access to good medical care, for example, could be within Europe or other places on this planet, if you have babies that come too early, that there was no good solution in keeping them safe in a way that you would usually do it within a medical facility, basically. So through the design thinking process, and you can read up on this also on their webpage, is that they generated this mobile backpack incubator that is now something that is standardized in a lot of places on this planet, which is low in its cost, but can actually save lives in a very simple setup that incorporates a lot of the needs that are addressed within the backpack, and then actually help to facilitate a transportation to the next medical care facility, which I think is a beautiful example on how to use something that has a big need and is very human-centered and incorporate a lot of great ideas in an interdisciplinary team through this process. Now, what I would like you to take with you is that this is something that you can use basically everywhere, also within your personal projects or your different work projects. But the reason why I called this Bridging Research and Industry is because I think as scientists, at least for me, we have a priming where we think everything through, and this goes nicely along with what Jamie was saying, that we're trying to analyze the problem in such a detail that we're losing a little bit the openness to be creative and trying to find innovative ideas to all sorts of problems. Then, of course, also the understanding of much needed skills. So within industry, you have fantastic backgrounds, all of you that are listening and are highly educated. But what we usually focus on is the hard skills that you learn within your education. But understanding that the power of methods like design thinking or lean or all sorts of different components can actually help you to have a unique selling point when it comes to getting a job, and trying also to identify what is needed in a team so that you can help out in that setup, which makes you more interesting for the company. And lastly, we're, of course, working in interdisciplinary and diverse teams. So working together is better. And I think, at least based on the scientific projects that I've done with a lot of different people, we're very good in working together, everyone in their own way and doing their own specialized part, and then bringing the results together. But we're not very good in collaborative idea brainstorming and benefiting from a different outside point of view on a problem in a way. That is something that is really focused on within design thinking and can help you also to improve your own skills in many aspects of it. And with this, I would just like to thank you for your attention. Feel free to reach out, and I'm happy to take any questions.
Thank you very much, Anne. Very nice talk, very insightful as well. So I can relate very much, especially with the iterative approach. I think it is very important, because just one short story, in project phases you have a design freeze at some point, and then the goal from there is to be in scope, so everything has to stick to the design. But if it's not helping anymore because things are too complicated, yeah, it's not helping the company. So you should be iterative and flexible. I like that a lot. So we have one question from the audience. Do LCA, so life cycle assessment, I guess, or environmental impacts matter in design thinking?
Yeah.
What do you say?
I think that's a good question, and in that sense, they do matter. Just because the idea is to find a solution for a specific problem. So if, for example, the environmental impact of something is the problem that you're trying to address, or if you're trying to find a more sustainable idea to address a certain type of problem, this is what you're going to focus on within the empathize and ideate phase, basically. So the nice thing is you can do this process on your own at home without any budget that is necessary for any problem that you have. And if you have something bigger within the company or something that is more complex, of course, you need designated time and capacities, but you can take into consideration and account whatever you want to in that sense. Personally, I always feel like environmental impacts need to be taken into account in any matter that we do. But yeah, I hope that answers the question.
Thank you. Yes, you mentioned that you are very much active in voluntary work and societal work. How do you, I'm sure you do implement design thinking there. How do you do it? Do you make workshops? Yeah. Can you evaluate more on that?
Good question. So yes, within the organization, for example, in which I'm working at, we had a certain problem on or about the structural setup of our legal advice that we're offering, and all the ideas that were discussed beforehand weren't really helping out or weren't really feasible. So what we decided to do is to take a step back and use the design thinking process to come up with something innovative for us in that setup. And we're successful in that way to try to find a new solution to something that might have been obvious for the outside in a way, but wasn't so obvious for us in the beginning because we didn't understand our own core issue. So, yeah.
And then, yeah, maybe you can share more detail. How do you plan to do it? So is it really one meeting that you're doing and then the leading person shares notes and to-dos, or how does it work?
You mean the practical components of it?
Yeah.
So what we did there was to use a full day just within the board members basically, and try to talk in the beginning to our clients. So this was basically a bit of preparation work beforehand with our clients and the volunteers to try to understand what are the issues that we're struggling with at the moment. And then during this full day, we went through the different phases and did a lot of iterations again on trying to understand, okay, so we had an idea, but that wasn't addressing the proper core issue. So maybe the core issue is still not there. And in the end of the day, we had a solution on how to solve the setup in a more or more flexible way for us within the capacities that we had. And we gave that a try and tested it for a couple of weeks. And then again, adjusted it to the needs that we identified during the process. Yeah.
Okay, nice. I think, or I'm sure everyone will try to implement it sooner or later. I know I will for our early career section. So if we face some new projects, we will definitely try out. Okay, thank you very much for your talk. I'm going to hand over to the next person. We are looking at talk number 4 now from Francesco Benedetti. Hi, and welcome to the stage. It is about the startup journey from idea to company. Yeah, welcome. You can start. Share your screen if you're ready. We see and hear you clearly.
I am. Do you see my screen?
Yes, we see your screen. So the stage is yours.
That's wonderful. Thank you so much. So good afternoon, everyone. It's morning here in Boston. So for me, good morning, but good afternoon. Or I think it's afternoon, right? in Europe now. So that's great. I'm very, very, very excited to be here. I am grateful for the invite. I want to thank you, Dr. Ksenia Papchenko, for the invite. My name is Francesco, and I'm CEO and co-founder at Osmoses. And I am, really grateful that I can share a little bit of my experience today and a little bit of my journey, because maybe it's not the typical journey of somebody that, after studying chemical engineering and doing a PhD, decides to do something that is, a little bit different, right? Which is, starting a company. So I would like to take everybody through, my experience, my journey, and hopefully leave some I think of messages that would be helpful for everyone here that joined today to think about the next steps and share some ideas, and looking forward for the questions eventually. So a little bit about me. I studied chemical engineering at the University of Bologna in Italy, where I'm originally from. And I had the opportunity to move to the US for the first time in Austin, Texas, at the University of Texas at Austin, to work on membrane technologies for desalination application, a project in collaboration with General Electric. I really loved research, and I decided that my next step was going to be a PhD. So I came back to the University of Bologna. I decided to stick with membrane technologies, but I switched the topic from water desalination to decarbonization involving gas molecules and gas separation. So always working on membrane technologies, but this time applying them to gas molecules rather than water and ions in general. This experience took me to the US again in 2017, where I spent a little bit of time in Stanford, and also then I moved to MIT, where I spent around 1 year completing my PhD studies, came back to Italy to graduate, and then decided to start a postdoc at MIT in 2019. Eventually, 2 years later, in 2021, starting Osmoses, which is the company that I founded out of the research project, one of the research projects that I was involved in the collaboration between MIT and Stanford. So just to bring everybody on the same page on membrane technologies and what a fascinating field that is. Really, research spans from anything around material design to scale up and eventually the largest applications at industrial level. So it's really, really a broad and very interesting field. And I've had the opportunity to work on a lot of innovative materials in my early days, where we were doing design of materials and testing, metal organic framework-based mixed matrix membranes, innovating polymer materials, and really trying to understand what their performance were and how their structures correlate to properties related to separations. So there's scale-up processes involved, really making films, making membranes out of these materials, and eventually, testing them, scaling up processes, really understanding the impact at industrial level. So it was a really fun journey and a great opportunity to learn a lot of fundamental science, but also keeping an eye on the industry, the market, and really getting a sense of how these technologies can impact industry and environment. So just to dig a little bit more about impact and about why separations matter. Maybe not everybody knows, but the cost of actually unmixing, separating, and purifying molecules is massive, both for the industry and for the environment. We are really talking about 15% of the world's energy and around 16% of carbon emissions that depend on separation processes. And the reason why these numbers are so big is because we still rely on century-old technologies to run these separation processes that are mostly based on thermal processes. And the society and industry really talks about decarbonization a lot. It's really one of the goals of this century. And hitting net zero is just not going to be possible if we don't bring innovation in the way we perform separations. So when my co-founders and I started Osmoses, we really decided to make our mission to rebuild their industrial infrastructure, where separations are not a bottleneck to a cleaner future anymore. And this is still core to what we do on a daily basis here at Osmoses. So when we think about what are the alternatives, right? I mentioned why those numbers are so big. Traditional separation processes, as I mentioned, are based on thermal processes. This is 90 to 95% of the industry. They're very effective, but at the same time, extremely inefficient. So if you were to literally boil off, components to get to the molecules that you want, there's going to be a lot of energy that is involved there. So there has been a switch in mentality around separations, and membranes have been, one of the most promising alternatives because they don't rely on thermal processes, but they operate as molecular filters, which means that they can separate molecules based on size. This delivers low energy consumption, but unfortunately, current materials, current membranes, in general, deliver poor separations, which leads to high operating cost and eventually low adoption, right? Which doesn't lead to impact. So what we're trying to build at Osmoses is a new family of membrane technology that still delivers on the low energy consumption that is key to why membranes matter, but at the same time improves selectivity, which is the ability of the polymer material to actually reject the molecules you don't want, which reduces operating cost, but also increasing flux, which is actually strictly like correlated to capital cost. So if you can maximize selectivity and permeability, what you end up having is a solution that is both cheaper on the operating side of things and the capital side of things, which makes a true alternative to redesign that industry that we were just talking about a second ago. So we do everything from really bringing patented new materials, scaling that up to make high-performance hollow fiber membranes, building a product and trying to understand how they compare not just against traditional membranes, but also against the non-membrane incumbent, right? Which is really where the biggest impact is. And this is all around, really separation process intensification, which is super important to achieve our net zero goals, reducing energy consumptions and carbon emissions. So when we think about the applications, we decided to focus on gas molecules that are the smallest molecules you can find, where there's probably the biggest unmet need in the industry when it comes to separations. And we have a platform technology that can serve in multiple verticals of the energy transition. There's so many gas molecules, as you all know, but the two that we are the most excited about are hydrogen and biomethane. They're both low carbon molecules that can replace, fossil fuels and other type of less, more carbon intense alternatives. And together with them, we also have applications in oxygen production, nitrogen, carbon capture, gas sweetening, and helium production. So what all of these processes, all of these molecules have in common is that better separations are key to lower the cost, lower the energy consumption and carbon intensity of these processes, which really means that by introducing better technology there, you can actually unlock the potential of these low carbon molecules really having an impact in the industry. And this really motivates us so much on a daily basis. So going a little bit more into kind of how I went through the process of starting the company and really what happened at different stages. I think the very first step was when we realized that we really had something special from a point of view of innovation and new materials. And at that point, we were in front of a crossroad. What are we going to do with this, right? There's so many opportunities. We could take this and make a research project and spin out an R&D lab, or apply for faculty positions and try to branch out and understand even more this technology. Try to license the technology for a large corporation to take it to market, right? But one of the options was, how about we, the inventors, try to take this technology, scale it up, and having the impact that, really enabling the impact that this technology can have. And I think that realization was very strong for me when, after writing, several times for applications or scientific papers, introductions that look a little bit like the one that you see here, that membranes really have the potential to substantially reduce energy consumption of industrial chemical separations, really having the chance to change the world in a way in the industry as we know it. I wanted to have the opportunity not to just throw this idea out there for somebody to pick it up, but be the one together with my co-founders to take it to the next level, to take it to the next stage and really vertically digging deeper there and achieving that impact. So really that was, I think, the very first crossroad and realization. Let's do something like this, even if it's not a traditional path. Let's try something that, looks a little bit risky, looks a little bit scary, but may lead to a massive reward. So this takes us to 2019, which is really where I started my postdoc at MIT, and this innovation was really shaping up. I had the opportunity to be selected by the MIT Energy Initiative and the MIT Deshpande Center for Technological Innovation, together with also MIT Sandbox, to do research in the Department of Chemical Engineering. And why these programs were so important in starting thinking about beyond the scientific research is because they actually help you translating and help me translating the scientific research into really what the market needs and what the industry is asking for, right? Which basically is the process of translating the features and the process and the properties of this technology into value. So it's a really big mindset shift when you're not just excited about the properties that a material has or the technology has, but you're asking yourself how this can help anybody out there, and does it actually make a difference, right? So one of the sentences that at that point for me became super important to think about is really making sure that we were not building a product that solves a problem that nobody has, which really means talk to customers, try to understand the industry, right? So with this realization and becoming more and more excited about this option, myself and my co-founders came together to think about actually spinning out the company. And here we have Catherine, Holden, and Zach. Those are really the founders and my colleagues that I started working with back in 2017 and 2018. And we're still all leading the organization today with expertise in material science, chemical engineering, chemistry, and a lot of other skills and interests that made us a good starting team to make something like this happen. So how 2021 looked like, which is the year where we launched actually this organization. So in 2021, in January, basically what we started doing is applying to awards and competitions to really get a validation from outside of the university if there was an interest in what we were building, if investors and the public and the companies were resonating with our idea. So we did things like the MIT Climate Tech and Energy Prize, the MIT 100K Entrepreneurship Competition, also enrolled to the Engine Blueprint program, all programs that really help people that take part to this program understanding if the idea matters, what are the opportunities, and is there anything here that we should really, really, really consider spinning out and incorporating, right, and doing something with. And May was a key month, and in particular, the last 2 weeks of May, because so many things happened at the same time. We became simultaneously Activate Fellows. Activate is a nonprofit organization that funds scientists on a mission to change the world, and gives like scientists 2 years of salary and also $100,000 to start working at, leaving basically the university and start working on building the company. We won the MIT 100K competition, the grant prize, so $100,000, which really made me feel on the top of the world, at least for one evening. And we also completed the I-Core NSF program, which is basically a program where you interview 100 customers and stakeholders to understand exactly if anybody cares out there about what we're building. We also won the Clean Tech Open Accelerator, and those things really launched us into started talking to investors, right? And that summer, we managed to close our first fundraising round, which was a pre-seed round of $3 million. And we got this very nice cover from Bloomberg saying that, a material that is thinner than human hair could slash carbon emissions. And we started working on really bringing together the team, scaling the technology, working outside of the university to develop our own IP. And it's been a very exciting year, and it's been a very exciting time. We did the Carbon to Value initiative in 2022. This is really to say, you see so many logos on this slide. And the idea is that all of these opportunities were super important for us to develop a better sense of what we were going to do and understanding if it was worth it in the first place and learning about the process and rolling in these programs. At the same time, I mentioned a lot of things that we got that were successful. I want to normalize a little bit this experience because there were probably more rejections and things that actually didn't work out than the logos that eventually ended up on this slide. But even just mentioning things around the logos that you see, the Activate program, we got it in 2021, but in 2020, I applied as a solo founder. And actually, I was rejected for the first time. So we need to take another year, develop a better application, bringing together a team, having better properties, better value proposition. And at that point, we got in 2021. The MIT 100K was eventually a great success, but it starts at the end of 2020 with its 3 chapters. And the first one is the pitch competition at the end of 2020 for our cycle. So we submitted the pitch. It was my very first pitch, 90 seconds, which is, insane to even think you can share an idea and think about, really presenting something as big as a startup idea in 90 seconds. But this is really what the time that you have to present an idea. And what happened is that we received an email that basically said, your pitch was not selected to continue to the finals. But they really, really encouraged us to continue our entrepreneurship journey. And we took that very, very seriously. That was hard to hear because, as we didn't know, right, if this idea actually was even appreciated, something that could matter to anybody out there. So getting the rejection definitely was not easy at that time, and it was the only data point that we had. But really, the same day, we also got this very nice email from one of the judges of the MIT 100K competition that basically said that our product seems amazing, and we are the kind of innovations that this judge gets really excited about. And that gave us a little bit of hope that we could actually try again, and we could actually keep pushing in the seeing if not letting that one data point defining us, but keep trying. And Stuart, by the way, is still today a mentor and an investor to the organization. So sometimes it's really just serendipitous meetings and opportunities that happen to you, and you don't even know that's one of the things that is going to make such a big impact and difference in your life. So we didn't get the pitch competition. Later on, we applied to Accelerate because remember they said, keep trying, keep doing this. This time we actually were selected to be among the 10 finalists, but at the live event we didn't win. We didn't get any of the prizes for the evening. And eventually we kept trying, and we applied for the launch competition in May, and that's actually when we got the 100K and we won the grand prize. So a lot of progress that we managed to make in 6-8 months working on this idea. What is super cool about these competitions is that you get to take a picture with something that is this iconic big check. And as you probably see, I'm not in this picture because when I've done all of these pitches in 2020 and 2021, you might remember that it was pandemic time, right? Really, everything was shut down, nothing was happening in person. So I literally pitched this organization to start with from my bedroom, literally. And it was very interesting that we never got the big check, we never got the iconic picture, but we still received the money. And with my co-founder Holden, we took this picture and made the perspective with the camera looking like it was actually a big check. So we tried to have that memory for ourselves. The year later, they were very kind and they brought us back to actually take a picture with the sign. So at the very least, we have that memory too, but never had the real big check. So since 2022, and after raising the pre-seed round, we focused on a lot of different things, from growing the team, scaling up our membrane technology, building prototype modules, enhancing our partnership with companies. And last year, around this time, we closed our seed round. There was $11 million, adding to the $3 million and other non-dilutive funding that in the meantime we managed to bring into the organization. And we're still using that funding for expanding our customer pipeline, bringing this technology to the field to pilot with customers, and eventually commercializing our solutions starting in 2027. Something that I'm very proud of and that truly was enabling this technology to move as fast as possible and creating an experience that I would not change for anything else in the world, was really growing the team, bringing some of the most amazing people, not just from the United States, but from all over the world, in what we call the most innovative square mile on the planet, which is Kendall Square in the Cambridge area in Massachusetts. And now we're a team of more than 20 employees with a well-rounded wealth of experience, from excellence in science and R&D, but also a lot of industry experience in everything that you need for scaling a company. And we're scaling commercial operations as well. We brought together a lot of investors that believe in what we're building. We have a lot of funding partners for non-dilutive grants and opportunities from the DOE, ARPA-E, NSF, and beyond, and also state level. And it's really a great group of people that are building something that is very mission-driven. In the last couple of minutes that I have, I wanted to share a few key personal learnings and maybe also some key takeaways for institutions. Some key personal learnings for me is that there are multiple career options at the end of a degree. And I think I wanted to invite everybody to keep an open mind because I grew up thinking that really there were two options: becoming a professor or working for a large corporation. And while these are amazing opportunities, not a lot of other options are presented, or at least were presented to me. So I think this for me is very important for everybody to know that there's more and you can be very creative, and sometimes you can be unexpected. Soft skills are as important as hard skills, and I think that's not conveyed enough when you're taking a degree in something like chemical engineering. Being a team player, learning how to communicate an idea you believe in with enthusiasm are probably as important, and I truly believe in that. Very important to work with others and collaborate. Problems are very complex, so diversity of thinking and background is the best way to solve them. Travel, take opportunities, or if you don't come up, create them for yourself, right? Just be as proactive as possible. Accept rejections, welcome them. Setbacks and failure, really part of the growth process. Resilience is key, and a PhD is a very good tool to develop plenty of it. Things never work out in the lab, as you know. So the market cares about value proposition, as we talked about, and developing a commercial product is tough and exciting challenge. So combining scientific excellence, operation experience, and industry knowledge is really important. A few takeaways for institutions for me are really helping creating excitement around entrepreneurship as a rewarding tool to solve big challenges. Programs like Activate and the MIT Deshpande Center are great examples for that. Financial and laboratory space supports are key for founders to spin out, and the engine model is really a great model that we should look into. And offer education about building a product that solves customers' problems is extremely important as well, focusing on value proposition, not just on technology. And initiating prestigious awards and competition so people are challenged to build a solution is key. And that will help us thinking, outside of the box. Facilitating transfer of intellectual property between the university and startup is also extremely important, and building a community of like-minded people at different stages of development. So with that, I really thank everyone for your attention and the opportunity to be here. And I would love to answer questions if you have them, and to stay connected with everyone. And thanks again for the invite.
Thank you very much, Francesco. Very nice to have you, and also a very insightful talk. I think it's good that it was the last talk, because now we have a lot of input from the soft skills coming, driving innovation coming, and then to start up. So thank you very much, and also for sharing your insights. Also, the drawbacks, I think, is a very important thing that you mentioned, and that you have to stick to it. Maybe can you share the point where it went to building strategies? So, for example, if we have in the audience some PhD students or students, what would you suggest to them if they want to make a startup someday, if they dream of it?
100%. So in my experience, really finding the right people to build it with was one of the most important things early on. I think coming from a technical background, didn't have management skills or a formal training around anything that means starting a company. So I think the opportunity of doing this with people, bouncing off ideas and sharing the burden of so many unknowns and making decisions when you have 20% of information that is necessary is truly key. So I think building a founding team that you trust, with people that you enjoy working with, is probably the first thing. And the second, being very passionate about the problem that you're solving, because you're going to have to stick to it and you're going to have to pitch it everywhere for like the rest of how long it's going to take for the startup to have the impact that you envision for it. So really believing in the mission and communicating it with enthusiasm.
Mm-hmm. Yeah, I agree. Thank you for sharing. And maybe you mentioned a lot of times the customer-centric approach. I also think it was a big part of in the talks before. When I'm in a PhD, how can I make sure that I have customers, or maybe how can I look for customers?
I think key is definitely there's a lot of incredible literature that is of course driven by scientific curiosity and is driven by really changing what we know about the science and research, right? And I think that's a great driver doing a PhD. But sometimes we don't include in that picture really where the industry is and what the industry needs. And not all research that needs to necessarily be targeted to solving a problem that is today's problem. Some research is solving problems that are 100 years from now, right? And that's still incredible research. But at the same time, depending on what drives you, I think if what drives you is impact today, really bringing the customer perspective and the market perspective in the picture earlier on can really inform looking for the best problem to solve. And for us, the better understanding of what the customers need helped identifying what type of materials we needed to scale, what type of materials were actually better for them, right? And made more sense of the research. And it was a very exciting part of, seeing the impact and making it as concrete as possible.
Thank you. Okay, so with that, looking at the time, I have one last task to do. I want to share with you the possibility of how to join our early career section. So I'm going to share my screen one last time before everyone gets to their days and afternoons, then continuing. So if you are interested into joining our early career section, just make a quick screenshot or come back to the YouTube video later. And then the very last thing, and most importantly, I want to thank all of the speakers and then participants for joining our call today, for joining our spotlight talk of the early career section. So thanks everyone. Have a great afternoon and day ahead. And goodbye.